Okay, here is the first problem we are going to do is in the integration differentiation set. So you see these ones in the Google Classroom I posted yesterday. Yeah, and here you see the first problem. So this problem is a calculator allowed problem because we're going to need that because these functions are kind of difficult. And well, we are going to begin. The tide removes sand from Sandy Point Beach at a rate modeled by the function r, given by r of t equals 2 plus 5 sine 4 pi t over 25. A pumping station adds sand to the beach at the rate of the rate modeled by the function s given by st equals 15t plus 1 plus 3t. This both r and t have units of cubic yards per hour, and t is measured in hours for 0 to 6. At time 0, the beach contains 2,500 cubic yards of sand. So here is the point. The first reading is critical in these problems, well, in any problem. So the two functions are rate of changes. So they are the derivative of something. So it's very important because it says here, it's at the rate, and remember in this class, a rate is a derivative. So this r, right? This r is the derivative of something. Now, of what? That's in the units. So r and s have units or cubic yards per hour. And then you have to think, okay, what do I measure with cubic yards? With cubic yards, I measure volume. And with hours, I measure time. So r and s are the derivatives of a volume function respect the time. T is time, correct? So it's very important. You said what you have to work with from the units. It's very important, cubic yards per hour. You engineers are necessarily going to work with units. So read the units and understand what you have to do. Okay, first question is, how much sand will the tide remove from the beach during the 6-hour period? Indicate units of measure. Okay, so I'm going to write my first function. This is r of t equals 2 plus 5 sine, parentheses, 4 pi t over 25, and that's my function. So I'm going to stop sharing, and here is the function, correct? So the units are cubic meters. Let me just find there I need. Integration differentiation right here. Okay, so they are cubic meters, cubic yards per hour. So those are the units, cubic yards per hour, correct? Now, so this is volume over time, correct? Volume over time. Now, the question is how much sand? Okay, you need, how much sand is a volume, right? In time 6. Yeah. Is how much volume, how much sand will be the tide removed from the beach during the 6-hour period? So I need V of 6 at the end of the 6 hours, correct? So now I have to relate these two, R with V. So if R is yards cubic per hour volume over time, then R of T is dV of T over dt. So R is the derivative of the volume respect the time, because this is a rate of change right here. Volume over time, correct? Now, this is a question we have to solve. Okay, I need the V. So I'm going to put here dV dt equals R, right? Then how do you cancel a derivative? Well, we cancel a derivative with the integral. dV dt integral respect the time, right? equals integral of r of t dt, correct? Now, this is going to be this, like these two cancels, you see, dt dt. This is the integral of the differential of volume equals the integral of the function r respect the time. Now, the interval of time, so is 0 through 6. This is what the problem says. So you want during the 6 hours lapse, so this is going to be from 0 through 6, and this is going to be from V0 through V6. This is volume. Volume is a function of time, correct? Volume is a function of time. So V of 6, V0 from 0 to 6. Then you know that the integral and the differential is, what is the antiderivative of dv is v evaluated from V0 through V of 6. This is a fundamental theorem. And this is the integral 0.6 RT dt, correct? Then, yep, the only you have to do is this is V of 6 minus V of 0 equals the integral 0.6 RT dt. And then, well, B0 is given in the problem, correct? B0 is given in the problem, so let me just go, share. B0 is, the beach contains 2,500 cubic yards of sand at time T0, you see, at time T0. So this is 2,500. So I'm going to move this to the right a little bit. So V of 6 is 2,500 plus the integral 0 to 6 RT dt, correct? That's my formula. Okay, now this is R, so I have to do this integral, but because this is a calculator allowed, well, I'm going to use the calculator. So let me just use the calculator. So is screen right here? No, this one, right here. So I'm going to add a calculator page. I open my calculator and I'm going to define the function R. Define, right, R of X. I'm going to put here R of X equals, and I'm going to type 2 plus 5 times sine of 4 times pi. I'm going to put here the pi times t times x in this case, times x, right, divided by 25. So if we define the function, we don't have to type it more, just when you have to, okay? So press enter, and this is okay, done. You see your function, 2 plus 5 sine 4 pi over x times x over 25. And then I'm going to do the integral. So I'm going to do 2,500 plus the integral. So I'm going to do menu, calculus, integral. And then I'm going to type what I have on my paper, 0 through 6. And I'm going, 6 right here. And then I'm going to put here R of X. R of X, I don't have to type the X again, dx. You see it's exactly the same formula on my paper. And then I press enter, and I get something strange. Well, if you have something strange, just press Control Enter, right? And then you get 2,531.82. So the type, so, well, the type, the volume, let me just, this is right here, 25.6, 531.82, correct? So let me just check the paper. So the sand at V, at V6 is 2531.82, correct? So, okay. So is the amount of sand that I guess is going to be removed from this part. Right? This is the volume of sand here. Now, In this case, how much sand the tide will remove from the beach during the 6-hour period? This is okay. The only thing I have to do is V of 6 minus V of 0 is 253182 minus 2500. So this is the net volume is going to be removed. So it's going to be very simple. It's 31.82 cubic yards, because these are cubic yards, correct? Cubic yards. Cubic yards. These are cubic yards, correct? So I have the amount of sand on the beach at the end in B6 and this one, correct? So this is the difference between B6 and B9. So this is what is going to be removed. This is, okay? So the tide is going to remove 31.82 cubic yards in 6 hours. Okay, question in this process. So again, I receive a function. Then this function is the derivative of another function. They ask me for values for this function inside the derivative. So to cancel the derivative, I have to apply the integral both sides, right? The integral of the derivative cancels. I need dv/dt is like these two cancels, dt's. And I have this one, then I set the limits of integration. So 0, 6 in this case, because they want from 0 to 6. And then volume in 0, volume in 6. So you see how I match the limits of integration here, this with this and this with this. So once I have this one, I perform my integration, right? And the difference, so is going to be what is going to be removed, because this is the initial volume. So this is going to be removed, correct? So that's it. Obviously, the volume of sand is there. Okie dokie. Questions? No questions?
No, that was pretty good.
Okay. Let's do the next one. So the next question. The next question is going to be this one right here. So this is write an expression for y, the total number of cubic yards of sand on the beach at time t. This is okay. Write an expression for yt, the total number of cubic yards of sand on the beach at time t. Now, again, you have to remember the problem, what you read at the beginning. So you have this second function, st equals 15t over 1 plus 3t. Okay, let me just put this one. So these are the two functions you have. Both functions are cubic yards per hour. So both are the derivative of a volume function, correct? Now, what you have to answer is, write an expression for yt, the total number of cubic yards of sand on the beach at time t. So, okay, let's see. Yt is total of cubic yards at time t, correct? Now you visualize this one. This is the tide. So this remove sand. This function tells you how much sand is removed. This is a pumping thing that is pouring sand on the beach. So this pours sand. So this remove, this, yeah, this adds. So simply, what is the total? Say, okay, y of t is going to be, you had at the beginning 2,500 cubic yards, correct? Is what you have. Then you add s of t, right? The volume of s of t, right? And you subtract the volume from the r of t. So this is the formula I have to put. This is okay. You have at the beginning 2,500 cubic yards of sand on the beach. You are adding with this machine this amount, this volume. This is the rate of change that you pour this volume. And then you subtract the volume that you, the tide removes with this rate of change. So the situation here is very simple, right? So how do you get these ones? So, okay, let's see. This volume and this volume. What is this volume? Well, this volume is going to be simple, right? This is going to be, okay, dv dt volume R, right? So dv dt equals R of t, and then I have dv s dt equals s of t. So this is going to be this one. This volume is going to be this one, bs, and this volume is going to be this one, right? So I need to find bs and b because this is volume. This has to be volume. So I have to do these integrals. So it's very simple. I'm going to have y of t, right, is going to be 2500, right, plus is going to be this integral. The integral, let me just put this one a little bit to the right. The integral of this function respect the time from 0 to t. So I'm going to put here 15s over 1 plus 3s ds. Why I put an s? Because formally you have to change the variable because you have this variable right here. Minus the integral from 0 to t of 2 plus 5 sine 4 pi t over 25. Well, in this case, I'm going to put an s also, ds. So this is going to be my expression. Obviously, having this r and s defined like this one, so you can put integral from 0 to t or rt or rs ds. No, más bien no. Is this one is b, is s, so it's plus the integral s of little s ds minus the integral, this is from 0 to t, from 0 to t, rt ds or rs ds. Okay, so this is a t and this is a t. Okay, so you see, remember what is the question? The question says, write an expression for yt, the total number of cubic yards of sand on the beach at time t. You don't have to perform this integral, it's just write an expression, okay? These expressions work. So it's just the analysis. I have this sand at the beginning, I'm adding this sand and I'm removing this sand. So the sand I had plus the sand I drop minus the sand I remove. That's the point, okay? You're going to use these conservation principles a lot, engineers, okay? So you have to be familiar with them. So everybody catch the idea here? The concept?
Yes,
okay.
sir.
Okay, let's now go to the next question. Okay, find, oops, right here. Is find the rate at which the total amount of sand on the beach is changing at time t equals 4. It's okay, let's see. So I'm going to write the expression I wrote before. Y of t is the total volume, so it's 2500 plus the integral from 0 to t s of s ds, vamos a ponerle mejor u, minus the integral from 0 to t r of u du. Okay. So remember, this is the volume of sand at time t. The initial, the sand you drop, the sand you remove. You want the rate of change, dy dt, when t equals 4. So what you have to do, because you want the rate of change, this is the derivative, So you have to take the derivative of this. Derivative respect the time of 2500 plus the integral 0t as u du minus the integral 0t r of u du, correct? And this is going to be evaluated at the time equals 4. Okay, now, basic calculus. Derivative of a constant 0. Derivative of this is the fundamental theorem. So the derivative and the integral cancels, and then you evaluate the function in t. So this is going to be s of t minus r of t. That's the same thing here. Now you have to evaluate in t equals 4. So this is going to be s of 4 minus r of 4. Correct? Now, what are my functions? This is, well, my functions are these ones, right? So I have right here my functions, you see, s of t. So I'm going to use my calculator. So I'm going to take here my calculator again, share my calculator right here. And I have already one. You see, I have defined this one. So I'm going to define now. Define, yeah, s of x equals, and I'm going to have parentheses 15 times x, parentheses divided by parentheses 1 plus 3 times x, parentheses. You see, that's my function. So the only I have to do is s of 4, yeah, minus r of 4. That is exactly what I have on my paper, you see. Press enter, and then I get that strange number, so control enter, negative 1.90875. So this is going to be negative 1.90875. And now the units, engineers, cubic yards over hours is very important. Okay, so when you write on your paper, you see this one is exactly what I have in our formula. So I put 4 here and 4 here in my calculator. It's the same as here. And then you get this operated by the calculator using the function you have in the memory. And this is 1.90875. Units, this is volume over time. Volume over time again. This is volume over time. So those are cubic yards per hour. Okie dokie?
Yep.
Okay. Another one, the last question, right here. This, for the time 06, at what time t is the amount of sand on the beach a minimum? What is the minimum value? Justify your answers. It's okay. There are different ways to do this one, right? So, so what you want is, I'm going to erase this portion only. So this is the amount. This is the amount of sand on time t, correct? This is the amount of sand. Y is the amount of sand on the beach at time t, or at time t really. Time t, all right? Now, this you need a minimum, so you need the minimum of y of t. How do you get a minimum? Says, well, you can take the derivative, solve to 0, or how can you get the minimum if you have a calculator? Says, well, suppose I have this one, and then the only I have to do is go to the graphing page, right? And then y is s minus r, correct? So I can do this one. So let me see. Let me see before this one, right? This is this is the condition for the minimum. Let me just write it because I skipped that. So minimum of y of t. So I have to take dy dt equals 0. This is the first condition. So dy dt is s of t minus r of t. And this is going to be 0. So I don't have to do the derivative. I can plot this one and check where this difference is 0 is what I'm going to do. So I go to my screen right here, and then I just go here and I put s of x minus r of x, correct? And then I press enter, and then I'm going to see here, okay, the negative portion is not interesting because this is negative times, so it makes no sense. So this begins right here. So I have to find where this cross the x-axis or the time axis. So it's here, you see? So menu, analyze graph, 0. And the only I have to do is this one. I can put my value here. And remember, if I need more decimals, I just go menu, settings, and put the float a little bit higher. And then I'm going to get 5.179. So for t equals 5.179 hours. So this is what I have. So minimum at yt, I need to solve dy dt equals 0. So dy dt is s minus t equals 0. From the calculator, I get, I put it graphically. You solve this one, and then you know that this a minimum y. It's very simple. Because the derivative, this is the derivative, this f1 is y dy dt, the derivative changed from negative to positive. And that's precisely the criteria you identify a minimum. Why? It's very simple. Because if this is the function y, this is the function y of t, right? Plus a minimum change from negative to positive the slopes, correct? So you have a minimum here. So this is my answer. These problems are crazy, right? Well, we're going to practice the whole week problems like this.
Nice.
The whole week. Okay. No questions? Well, just the practice is going to make you understand. But I think every one of these steps is pretty much clear. And the practice is going to make you master this thing.
Hey, Mr. Ramirez, instead of giving us homework, like, you know, the one that we were supposed to turn in on Saturday at 11, can you give us homework, like, can you tell us what problems to do, like, each day and give us, like, one problem so we could try to do it and do it by the next day?
Problems like these ones?
Yeah, well, yeah, for the test.
Bueno, pues acuérdate dónde
like
están.
Us.
So, maybe you, espérate. Okay, here, cancel. So in this case, if you have this one, acuérdense, aquí están, let me just show you, right here. Okay. Okay, I'm going to share screen. You see the Google Classroom for the PreAPPreCalculus AB test, our classroom in Google. Here, I always post the problems. All this here is the PDF I'm showing you here, right? So in this case is all these problems are right here. So all the problems I'm going to work with you, all these ones are in that file. So you have to check them, download them, print them, I don't know, whatever you can do. And then this is the practice, okay? I don't have more practice for this. This is the practice I give for the test, okay? So vamos a hacer uno más. Let's do one more, right? Pretty much all of them are going to be the same. You are going to see that this is very, very repetitive. So we have now this problem. You have a function of the time. You see here the t right here. And then this is a value function and then the function increases, decreases, increases, decreases, correct? And goes from 0 to 18. Is it? At an intersection in Thomasville, Oregon, cars turn left at the rate L of t, 60 square root of t sine square of t of 3 cars per hour over the time interval 0 to 18 from here to here. The graph of L is shown above. So this is the rate of change. So at the 5 hours, you have a max. So 5 hours after you begin this experiment, right? The rate of change has a maximum. Then the rate of change decreases and becomes practically 0 at 9.5. Then increases after noon by pretty much 2, right? Of 14 hours after you begin the counting, and then the rate decreases. So you know there are hours that the traffic is more than other hours, right? So it's pretty much what the function shows here. So I'm going to put here L of t equals 60 square root of t sine square of t over 3 is from 0 to 18. So this is the problem here. This is the question. And again, the units are cars per hour. So cars per hour. So these are the units, number of cars per hour. And then you have the behavior of this function over there. Obviously, this problem is a calculator allowed problem, so we are going to use calculator. Usually these problems are calculator allowed, right? So let's go to the screen again. This is okay. To the nearest whole number, find the total number of cars turning left at the intersection over the time interval from 0 to 18 hours. Okay. So again, this one, right? This is the rate of change cars per hour. So L of t is the derivative of certain function n respect the time. What is n? Number of cars, remember, is cars per hour. So cars per hour, dn dt. So it's the way you determine who at function is going to be the one you have to find. So they say, what is the number of cars that turn left during 18 hours? So it's okay. To find this one, so I need n of 18, right? N of 18 minus n of 0, minus n in 0, correct? So this is the number of cars in the interval 0, 18. So this is the total number of cars turn left during these 18 hours. So it's what you have to find. Okay, how do you find the n? Again, same as before. You cancel the derivative using the integral. So I'm going to integrate L of t respect the time, correct? Now, what times? From 0 to 18. From 0 to 18, and this is going to be from n in 0 to n 18. You see, n 0 and 18 right here in this derivative. Now, this cancels, so this is going to be n 18 minus n 0, same as in the previous problem. The integral from 0 through 18 of 60 square root of t sine square of t over 3 dt. Okay. So you need this integral, correct? Obviously, this integral is not possible to do it by formulas, right? So we have to do the calculator. Okay. So let's go to the calculator right here. I'm going to open a new document, right? I don't save. I'm going to put a calculator. And then, well, if I don't want to type this again, so I'm going to do the same. Or you can do define, or you can plot. Let's just plot a different method. So I'm going to type exactly this one. 60 times square root of x. So I'm going to put here the square root of x, then times parentheses. I'm going to put sine parentheses x over 3, x over 3, and then a square. Okay, now I can adjust the window. So let me just put here window zoom. No, right here. Current. So I'm going to put menu, zoom, window settings. So the time goes to 20. Let me just put here 20, 0, next. And why me? Let me just put here a 20, possibly is going to work. No, it needs more. So menu, right, is 250. So I'm going to put here then. Let me just put here 300. 300. Okay, you see the function, right? Pretty much the same function we did. Here is the function. So it's the function in the graph. Obviously, I have more because I put it till 20, but this ends in 18. Okay, now, if you want to work this function, it's okay. I need to do the integral. So I'm just going to do this. Menu, calculus, integral. Then I need the integral from 0 through 18. Right here, 18. And then I'm going to put here y1 or f1 because it's the function right here, you see, f1. So I'm going to put here f1 of x dx. What is going to give me this function? Well, this integral is going to give me the number of cars turning left. And you see, is the area under this curve. That's the number of cars. That area represents, the value of that area represents the number of cars. So you have 1,657.82, so that we are going to round to 1,658. Because you don't have a portion of car passing, so car pass or not. So you have that answer, cars. Questions here? You see the same procedure. This L is the derivative of something. I need values of this function that is under the derivative. I use the integral to cancel the derivative. So I have to integrate this function. And depending on the value, this is from 0 to 18 in this interval of time, I integrate from 0 to 18. Then when I have this is the number of cars on that interval, really. So the number of cars at time 0, is this possible 0? And in 18, so I don't know this one, that's why I put 0, but possibly you can begin at 0. But whatever is the number, in this interval of time, you have the number of cars in 18 hours, 1658. Okay? Well, let's see now the next question. The next question is, traffic engineers will consider restriction. Let me just show you here. Okay, traffic engineers will consider turn restrictions when LT more than 150 cars per hour. Find all values of T for which L is more than 150 and compute the average value of L over this time interval. Indicate units of measure. Okay, let's see. You have here the graph. You see this graph right here. Now 150 is y equals 150 is this horizontal line, you see? This horizontal line. Okay, now you want the average value of this function on the graph, right? During the moments this is more than 150. So I'm going to do that in the calculator. So I have now share screen, calculator. And what I'm going to do now is I'm going to put this one right here. And then I'm going to control graph. I'm going to put here 150. Press enter and I see the line. This is when the rate of cars per hour is more than 150. This is a rate of change. So I need to find these two numbers. So I'm interested of the average value of this portion of the function, correct? So okay. So I'm going to do menu, Windows zoom. I'm going to do, no, analyze graph. I'm going to do intersection. So I want this intersection. I'm going to put it right here. And I'm going to do another intersection, right? This and this. So I'm going to put this one right here. Okay. So I'm going to put here the two intersections. And because these are a few decimals, I'm going to put menu, settings, float 5. And then I'm going to have now enough decimals to work. Remember, AP test requires at least 3 decimals, okay? So what I have to do is, well, what I have to do is get the average value of this function. So what is the average? So what is the height that is going to give me the same area between these two lines, the red and the blue? Okay, how do you represent that? So it's very simple. So L of t more than 150 for 112 for 28 greater or equal than t lead or equal than 16 122. I'm writing those numbers on my board. So this is the point right here. L of t is greater than 150 for this thing. So from the calculator, I found that between these times, the curve is above. So it's something like this, correct? So what I need is the average value. So I need a height. And this height is going to be computed in this way. So you have the rectangle, right, whose height gives me the same area as the parabola or this curve. So how do you do that? This is okay. Average value is 1 over the difference of these two, 16.122 minus 12.428, right? Integral from 12.428 to 16.122 of LTVT. So you have to integrate this function between these two values, right? And then you divide by that one to get a rectangle that is going to give me pretty much the same area. Something like this, correct? So, not a big deal. I'm going to use my calculator to do this thing. Now remember, I don't have to type the function because it's already here. So I go here and then I put okay. So I have 1, no, this is 1 divided parentheses 16.122 minus 12.428, yeah, times, now the integral, menu, calculus, integral, and then I put here 12.428, I put here 16.122, and here I'm going to put the function f1 of x dx. You see, I don't have to type too much, just the numbers. Okay, so this is my average rate, and it's going to be 199.417. Okay, Rangel, you round up or you round down?
You round down.
You think? What do you think, Arely?
Because it's cars, right?
Yes, it's cars, the number of cars. You cannot have 4.147. So what you want, 199 or 200? Arely, what do you think?
199.
What do you think, Arely?
199.
Okay, let's put 199 cars. This is the average number of cars in this interval, correct? Remember the graph. the graph here, well, not here, really in the calculator. Let me just go back to the calculator, right here. In the graph, this is 300. So this, I don't know this max. Let me just locate this max menu. Analyze graph, maximum, right here, from here to here. So my maximum is 226 cars, 0.23. So, and here you have 150. So in this time is 199. So it's a value in between these two, 150 and 226. You see, it's between these two. So that's an average. Okay. You remember this formula? Remember, Ali? This formula, we use them when we got the average velocity, remember? And we don't take velocity final but plus velocity initial divided by 2. Remember we did the integral like this? Okay. Bueno, let's finish with this. And I have question number Z, the next questions, right? Oops. Here is the question. No. Okay, here it is. So the last question is, traffic engineers will install a signal if there is any 2-hour time interval during which the product of the total number of cars turning left and the total number of oncoming cars traveling straight through this intersection is greater than 200,000. Whoops. In every 2-hour time interval, 500 oncoming cars travel straight through the intersection. Does this intersection require a traffic signal? Explain your reasoning that leads to this conclusion. Yeah, this is kind of weird, right? So they want to install a signal if there is any 2-hour time interval during which the product of the total number of cars turning left and the total number of oncoming cars traveling straight through the intersection is greater than 200,000. Dice, on every 2-hour time interval, 500 oncoming cars travel straight through that intersection. Okay. Does this intersection require a traffic signal? How can we know we need a signal? What do you think? What can we
look
do?
at the graph?
Well, we can see the graph, but this is not the, well, not here. Let me just, not this one, share screen, this graph. So you see the graph, it's okay. This is not the number of cars. This is the rate, okay? The number of cars is going to be given by a different function, correct? So what function is that? This is, well, what's
The
right
derivative
here?
or antiderivative?
Now the integral. Remember,
Integral, yeah.
let me just, L of t is, well, in this case, L of t is 60 square root of t sine a square of t over 3, correct? T over 3. So this is the rate of change. So this is the n dt, correct? So you need cars, you need product. This is 500 times n, correct? Must be what? This is the product. This is the product. Yes, aquí. The product of total number of cars, n of t, right? Turning left and the total number coming cars. So every 2 hours you got 500 times this number, correct? So this has to be more than what? 500 times n of t more greater than 200.
4,000? No. 400?
Puede ser. So, but at what time? When this happened? So, does this intersection requires the signal? So, is there any time for which nt is more than this number? How can we know that?
No, there isn't. Or wait, no. Actually, I don't know.
So this is L of t. N of t is going to be the integral from 0 to t of 60 square root of t sine square of t of 3 dt. Or we can put here a different variable just to be consistent with the people in college board, right? So N of t is this one. So 500 times this integral has to be more than 200,000. So is this integral more than this? What do you think? How can we know this? So you can move
Evaluate
this
it.
500 here. So if you move this by this integral has to be more than pretty much 200,000 divided by 100,000 serían 400, right? Yeah. If we divide this by 500, we cancel 2, son 400, correcto? 20,000 divided by 5 is 400. So this integral has to be more or equal than 400. So this means that this area, right, is this area right here. All right, stop share, go to share again. This area has to be in a certain moment more than 400. Do you think it's going to happen?
No.
Well, there is only one way to know
Oh,
it,
you said the area?
the area.
Oh.
What is the maximum number of cars we got? Remember the answer for the first question? To the nearest whole number, find the total number of cars turning left over the 18 hours. And remember, there are periods of 2 hours. So in this portion right here, in this portion right here, you see, in this interval, in this interval, in this interval, in this interval. So do we have that one? So
Yes.
where do you
I
think you can work? Where?
The highest point, the second max.
And the second max? That's correct. Yep. So the second max here is 14,294. So 1494 is between what values? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's going to be between what? And 14 and 16, 15. Correct?
Oh yeah, that's too.
So 14 and 16. So let's see. So how can we write that one? So is 500 the integral between 14 and 16, 60 square root of 4 u sine square u over 3 du, correct? Let me just show you what I wrote. This one. So between 14 and 16 is intervals of 2 hours. 0, 2, 2, 4, 4, 6, 6, 12, no, 6, 8, 8, 10, 10, 12, and so on. 14, 16, that's the interval because the maximum is between what? 14 and 16, correct? Well, let's see. Let's compute this one. So with the calculator again. So this is going to be, let me just share the computer here again, this one. So I'm going to take 500 times integral menu, calculus, integral from, let's just 14 to 16. And then you have here f1 of x. f1 of x dx. dx. Okay, enter 206,133. Is that more than 200,000? What do you think?
Yeah.
Yes, it is. So there is an interval of time, 14, 16, correct? Between in which the cars are 206,000. So between these two intervals, possibly the signal is going to work, right? We can do the same for instance, for 12 and 14. Let me just do that. For 500 times, and I'm going to, well, I'm going to do the same. This one, let me just take this one out. And then I'm going to put here 12 and 14. Let me just the previous 2 hours interval, 181. So now, between 12 and 14, you have 181,000. That's the product. So you don't require the signal. But between 14 and 16, you have more than 200,000. So you require the signal. Okay? A ver. Now, how can you answer this one? Once you check this, and I want to write this one, in your best English, how can you express that answer? Explain, because here the problem says explain your reasoning. Can you explain all the thing we did? I will try 1 minute.
Can you just put like from the time period 14 to 16 hours?
Mm-hmm.
The cars, what was it, like it was like total amount of cars, right?
Yes, the total number of cars times 500 is more than 200,000, right?
Yeah, it
So
exceeded the 200,000 amount.
Correct. But remember, this is basic, and obviously this is equals, let me just put it here, was 206, right? 206, let me see. Oops, no, this one. 133, okay. So, okay, here, let me just put it right here, okay, there it is. So this is the total number of cars. This is more than 200,000. So signal necessary from 14 to 16, correct? Because you determine this from your calculator. This is okay. I'm going to put this one. This is my reasoning, right? Then I'm going to check the graph. The maximum area occurs more or less between 14 and 16 because the maximum is over there. And then this is okay. From this integral is 206, 133 is more than 200,000. So signal needed from 14 to 16, correct? These problems are tough, right?